everyone, and welcome to Virtual Planetarium, Exploring Space, part of our MOS at Home programming. My name is Janine, my pronouns are she and her, and I'll be your moderator today. That means that I'll be reading some of your questions and responses, which you can submit below using the Q&A button at the bottom of your screen here in the Zoom meeting. If you'd like to see captions during today's program, you can click on the Closed Captions button at the bottom of your screen and select Show Subtitles. And if you're joining us on Facebook, hello! We're so excited to have you here, but unfortunately, I'm unable to see anything that you post over there. We are so delighted to have you all here today as our audience. Let's meet our guides for our journey through space.
Hello, everybody. My name is Talia. I use she, her pronouns, and I'm going to be your presenter today, but I can't do it alone. I need a little help.
Hi, everyone. My name is Katie. My pronouns are she and her, and I'm going to be your pilot for most of the program today, flying you through the solar system.
Yeah, because today we're going to be focusing on a couple of solar system objects that you can see and maybe you have spotted in the evening sky. And these are things you don't need binoculars or a telescope to see. You just need your eyes, even if you are in the middle of the city. And I'm going to show you how to find them in the night sky. And then Katie's going to take us out into space where we're going to explore them a little more in depth. So to start off, I'm going to share my screen. And we are looking at the night sky the way it would look at around 9 o'clock tonight from the Boston area. And obviously, if you're in Boston, you're not going to see this many stars because we have a lot of light pollution in the city. And that washes out stars. But the objects I'm talking about don't care about light pollution. So right now we're looking to the north. I'm going to swing us around so that we are actually facing south. And here we go. We, of course, have the moon, which is nice and pretty easy to spot. But over here, we have our targets for the day, Jupiter and Saturn. These are very, very, very bright planets in our sky. You can spot them even in the middle of the city. And for most of Boston, you're going to want to be sort of looking upstream for the Charles. So if you're in the major Boston area, anywhere near the river, you're going to be looking sort of upstream from the Charles. Just look for the brightest things in the sky that are not the moon. Jupiter is the fourth brightest natural object in the sky after the sun, the moon, and Venus. And Saturn is very, very close to it and also very, very bright. So you can spot these easily in our nighttime sky. And of course, these are planets of our solar system. So what you're seeing are objects that are, in Jupiter's case, about 500 million miles away, and in Saturn's case, about 1 billion miles away. And, you know, spotting them with your eyes is fun, but let's say you want to know a little bit more about them. To help us learn a little more about them, Katie is going to take us out into space. And we are going to go explore a little bit. So right now, Katie is using a program called Open Space, which is free to download. It is a bit of a beast of a program if you want to try and download it, fair warning. And we are going to start, we're here in orbit around the Earth. We were just looking at the sky as you can see it from Earth, but let's go visit some planets. So the closer of the two that we were just talking about is Jupiter. So we're going to start there. And again, I say close. Close is a very relative term. If you were moving at the speed of light, it would take you about 45 minutes to get from Earth to Jupiter. It is about 500 million miles away, you know, give or take a couple dozen million miles. It is the largest planet in our solar system. It is one of the outer planets. There are 4 of those, and those are Jupiter, Saturn, Uranus, and Neptune. And they are different from the inner planets because the inner planets are small rocky worlds, and the outer worlds are what we call gas giants. And Jupiter is the giantest of them all. It is so big that you could fit over 1,300 Earths inside of it. If Jupiter was, say, hollow and you wanted to fill it up like a big cookie jar with Earths, you would need over 1,300 Earths to fill it up. And that's not the only extreme thing about Jupiter. I mean, people tend to know that it is a very, very large planet. but it also actually spins faster than any other planet in the solar system. So Earth, our planet, takes 24 hours to rotate on its axis once. That is the length of its day is 24 hours. A day on Jupiter is only about 10 hours long. So not only is it huge, it's actually spinning very, very, very rapidly, particularly for something of its size. And that rapid spinning is actually what breaks its atmosphere up into those stripes, which you can see, which are very sort of distinctive. They're not quite, they're what you see on any other planet. You don't see atmospheric bands quite this distinct. And that is due to the fact that Jupiter is spinning so quickly. And you do get a lot of air moving very quickly then, which does mean a lot of storms. And this is a planet that is basically all atmosphere. So it is the perfect storm, if you will, for making storms. And Jupiter is covered in them. Anywhere where you can see sort of an oval or a dot shape, Katie's pointing a few of them out. Those are storms, big storm systems on Jupiter. The planet is a storm factory. And of course, it has one storm in particular that it is famous for. Does anybody happen to know the name of that storm? Feel free to put it in the Q&A if you know the name, or you can always put a question mark if you don't know it. One storm on Jupiter that is particularly famous.
Oh, we have an answer coming in, and they're saying the Great Red Spot, and also some question marks.
The Great Red Spot is in fact a storm on Jupiter, and it's, you know, a little bit, it's a spinning storm, so it's kind of like a hurricane on Earth. I know hurricanes are really in the news right now, thanks to Laura and Marco in the Gulf of Mexico, but you know, those are pretty big storms, right? Laura and Marco, those hurricanes that we see on the Earth, they can be, you know, we can get hurricanes up to like 1,000 miles wide, and they can last for weeks, and they are absolutely nothing compared to the Great Red Spot, which is a couple of Earths wide. It has varied in size over time from between 1 to 3 Earths wide. So you can measure it in Earths. And it's right now, it's about 1 Earth wide. It's actually been shrinking over the last couple of years. And it has been raging for at least 400 years. I say at least because 400 years ago was when somebody first looked at Jupiter through a telescope, which is necessary for spotting this storm, which Katie has just brought.
Finally.
Perfect.
It was hiding for a while.
It was on the nighttime side. And there it is, that big red oval. That is the Great Red Spot, an Earth-sized storm that has been raging for at least 400 years. And again, 400 years ago was the first time somebody looked at Jupiter through a telescope. It's probably actually much older. We don't know how old. So unlike a hurricane, which, you know, runs out of fuel when it moves from being over water to being over land, there's no land on Jupiter to slow this storm down. So it's just perpetually raging. Now, most of these things I've talked about the size, the speed with which it spins, the way that the atmosphere is built, the storms that we can see here in the upper atmosphere. These are all the outside of Jupiter, things we can tell by looking at the outside. And for a very, very long time, we had absolutely no idea what was going on the inside of Jupiter. In fact, the insides of the gas giants was sort of a mystery for a long time, but it's a mystery we're starting to solve. We have a spacecraft in orbit around Jupiter right now. Its name is Juno, and its job is to actually look for tiny little changes in Jupiter's gravity. And we use those changes to figure out what the inside of Jupiter looks like. And it's kind of crazy. We're not sure what's exactly, it's a little bit weirder than we expected in there. And, you know, we were expecting something a little weird. It looks like the center part of Jupiter may actually be still resonating from an impact that Jupiter suffered billions of years ago, which would have had to have been a really big impact. And it would have been while the solar system was pretty young, and Jupiter would still be feeling its effects, which is pretty incredible, especially for an object of this size. Now I keep talking about the size. Again, this is a very massive object. It has a lot of gravity, and a lot of gravity helps you hang on to a lot of moons. So in case you were wondering what all of these yellow lines out in space are, these sort of golden lines, these are the orbits of Jupiter's moons. Now, for most of human history, we knew about more moons, or human observational history anyway, we knew about more moons going around Jupiter than any other planet, since we started using telescopes. That's no longer the case. Jupiter currently reigns second in the moon count with a mere 79 moons. We'll get to the Moon King a little bit later, but some of these moons are really fascinating little worlds. So Katie, can you just swing us by Io? Io is one of Jupiter's 4 largest moons, which are named for Galileo, who first spotted them through a telescope. They're called the Galilean moons. And Io is a very unattractive place. Io looks like moldy cheese. What's actually going on here is that Io is covered in volcanoes. It's the most volcanically active place in the entire solar system. All of those circular features and those things that look like pockmarks on the surface, those are volcanoes. And Io is so volcanically active because of Jupiter's gravity. Jupiter's gravity actually pulls on Io, and it makes it flex and actually makes the rocks inside of it rub together. And if you've ever rubbed your hands together really, 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 really hard and you felt them get really hot, that's friction. And the same thing happens to all the rocks inside Io as it's flexing. A lot of heat builds up inside the moon, and it gets rid of that heat through volcanoes. So the reason for Io's moldy cheese appearance is actually because of the material that's getting shot out of these volcanoes. And it means Io has one of the youngest surfaces in the solar system, which for a moon with no atmosphere is pretty weird. Moons with no atmospheres tend to have very, very old surfaces, but Io is constantly being resurfaced by these volcanoes. Now, Io is not the only moon of Jupiter where Jupiter's gravity has an effect on what the moon looks like. But we're going to take a step out to the next moon out, the moon Europa. And we've got a very different effect of Jupiter's gravity. I think we might be going straight through Jupiter to get there.
Right through Jupiter.
Excellent. So Europa, which we're coming up on the nighttime side of, is a very different looking world than Io, because Europa is covered by this thick crust of ice. That's not rock you're seeing, it's ice. You can see big cracks in it. And what's fascinating is there's heat being generated inside Europa, just like inside Io, but instead of powering volcanoes, it's keeping a liquid water ocean in existence. Under the crust of Europa is a liquid water ocean. In fact, we believe there is more liquid water under the surface of Europa than there is on the surface of Earth. And of course, we get pretty excited whenever we find liquid water because life as we know it needs liquid water to survive. And Europa's got a lot of it. Now, we don't know if life could form and survive under the surface of the moon of a gas giant, but if it can, Europa may be a very good place for that to happen. And so we are designing a mission called the Europa Clipper, which is going to come out here and take a much closer look at this moon. And that's a NASA mission. There is another mission from the European Space Agency in the works. It's called JUICE, the Jupiter Icy Moon Explorer. And we're gonna, because we really want to know a lot more about what's going on here at Europa. We think if there is life out there in the solar system, Europa is one of the best places to look for it. So now that was a huge info dump about Jupiter and just a couple of its 79 moons. While we are still here in orbit around Jupiter, Janine, are there any questions I ought to answer?
Yeah, we have a couple questions. Prisha, age 8, wants to know how Jupiter got that red spot.
So we've watched storms form on Jupiter. It's usually, you can see, actually this is a good shot because you can see where the storm is. It's right on the edge of two of those bands. And that is a good place for these storms to form because one band will be sort of moving in one direction and the other band will be moving in a completely different speed, sometimes in the other direction. So it's a great place for big swirls of air to start forming. And as those get more and more powerful, they develop into these storms. And in this case, this storm got so big that it is self-sustaining. And it's been there for hundreds of years, at least. So that's where you're going to find the really powerful storms right where those atmospheric bands meet.
Elizabeth, who is 6, wants to know how Europa got the layer of ice.
Europa gets its layer of ice because its outer layer is exposed to space, and space is very, 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 very cold. It should, in fact, it's far enough from the sun that it should probably be ice all the way through, except that, again, Jupiter is pulling on it and making it flex just enough to heat up its insides a bit. And that heat from the inside is what's keeping those intermediate, those middle layers liquid. So icy moons are pretty common. Ice is very, very common in the outer solar system because it is so very cold. It's that liquid layer that's the exciting part.
And I like this question from Kira, age 8, who wants to know, why does the ice on the moon look gray?
It sort of depends on what filter you look at it through, but because I have seen ones where the cracks actually almost look reddish. It depends what camera filter, but space is not clean. There's a lot of space dust out there, and Europa does get hit by things like asteroids, which pound themselves into the surface, and so then you get dust on it that way. So Europa is not pristine. In fact, very few things in the solar system are. Because there is a lot of space dust out there, and because if you're going to get smacked by an asteroid, then you're going to have little bits of rock spraying all over the place, and that is going to make it so you're going to have a little bit of a layer of space dust. But I think it's time for us to head to Saturn because we have a whole other planet to go check out. So Saturn is the next planet out from Jupiter. Jupiter is the 5th planet. Saturn is the 6th. Jupiter is the largest planet. Saturn is the 2nd largest. It also has an array of moons, as you can see. In fact, Saturn is the reigning moon king. For so long, we knew of more moons going around Jupiter than around Saturn, but just last fall, we discovered 20 new moons that we hadn't previously known about going around Saturn. So for right now, Saturn is the reigning moon king with 82 moons. And we'll get back to the moons in a moment. But first, if we're going to talk about Saturn, we got to talk about those rings, those gorgeous, gorgeous rings. So Saturn's not the only one with rings. In fact, all 4 of the gas giants have ring systems. Jupiter, Uranus, and Neptune also have rings. You might be saying, well, wait, we were just at Jupiter. I didn't see any rings. And that's because Jupiter's rings are sad and pathetic, as are the rings around Uranus and Neptune. They are really, really faint. They are really, really wispy. There is not much to them, and they are mostly made out of dust. And Jupiter's is actually the saddest of them all. Saturn's rings, on the other hand, are enormous. If you go from one side of the main rings all the way to the other, it's actually most of the distance from the Earth to the moon. And they're made out of something very, very bright and reflective. They're made mostly out of ice. Here's another place where the ice doesn't look nice and pristine and white. It's got a bit of a yellowish tinge to it. But that's most of what's going into making up these rings. And ice is very reflective. It makes the rings very, very bright. You can see these rings through binoculars, a good pair of binoculars or a small telescope. You can see the rings of Saturn. It doesn't take much magnification. Galileo was able to see these rings. He didn't recognize them as rings. He did think it looked like the planet had ears. And these rings, we think, are temporary, very temporary. We think they're very young in terms of ages of things in a solar system. They're probably only about 100 million years old, which sounds like a lot to a human, but to a planet, that was yesterday. They're very young, and they're not going to last very long. Maybe another 300 million years. So that's actually a very brief period of time in the history of the solar system that this huge spectacular ring system is going to exist. In a few hundred million years, it may look like the sad, pathetic rings around the other planets. Now, the planet itself is pretty cool as well. It is, like I said, it is a gas giant, second largest in the solar system. You could fit 753 Earths inside of Saturn. And so that means, like Jupiter, it is very gravitationally powerful, which helps explain its huge array of moons. And it, just like Jupiter, has some very unique worlds in orbit around it. So Katie, let's start with the moon Enceladus. So Enceladus is kind of a smallish moon, but it has a lot in common with Europa. Like Europa, Enceladus is covered with a thick crust of ice. And like Europa, underneath that crust, there is a liquid water ocean. Now, what's different is Enceladus is doing us the favor of actually shooting that ocean out into space through big cracks near its southern pole, which actually allow geysers of water to come out. And we've actually been able to fly a spacecraft through it, the Cassini Spacecraft, which spent 13 years in orbit around Saturn, learning about the planet and its rings and its moons. And it actually flew through the plumes from Enceladus's geysers and was able to determine that not only are they coming from a liquid water underground ocean, but that ocean probably had hydrothermal vents on the seafloor. Now that's very exciting because we think the hydrothermal vents on Earth's seafloor may be where life began. It's a food source. It would be a way that life could get energy. And we think Enceladus has them. We think it would be a great place for life to survive. We think we actually know of certain types of life on Earth that if we brought them to Enceladus and put them in the ocean, they would survive there just fine. So Enceladus is another place we are very, very excited about if we want to find life as we know it. But I keep talking about, Europa and Enceladus. These are places with their liquid underground. Let's say, you know what? You're from Earth. You want your liquid on the surface because that's how we do it at Earth. Well, you can have liquid on the surface here in the Saturn system as well. So Katie is taking us to Saturn's biggest moon, Titan, which is the size of a small planet. It is about the size of Mercury. And unlike any other moon in the solar system, as we fly around, you can see, well, this is actually not really what Titan would look like. Titan actually has a thick, dense atmosphere. It's actually so thick that if you're there at Titan, you can't really see the surface. All you can really see are the tops of the clouds. But we know that on the surface of Titan, there are rivers, there are lakes. It rains on Titan. You could step in a mud puddle on Titan. It's just not liquid water. It is liquid methane, which is something that we see as a gas here on the Earth, but Titan's very cold. So what is a gas on Earth is a liquid on Titan. But that makes Titan, which has, again, rain and rivers and lakes, it makes Titan the only place other than Earth that has a constant liquid on the surface. It has a methane cycle, just like Earth has a water cycle. And there are some people who say we think about life too narrowly. We always say that life needs liquid water to survive. What if it just needs a liquid? Titan's got a lot of a liquid on its surface. If there is a form of life that could survive on liquid methane, Titan is the perfect place for it. And we are designing a mission to go back to Titan and take a closer look at it. And I'm very excited about this one. It's called Dragonfly. And it's going to be a quadcopter, well, an octocopter. It's a drone. We're going to fly around on the surface of Titan one day. I'm very excited about that one. I see we're running out of time. I want to keep talking about all these moons, but Janine, are there any questions about Saturn and its moons I should answer while we still have time?
There's one that's coming from a bunch of people about Saturn's rings, which I think can be related to its moons, which is how do they form?
We think they came from a moon, actually. We think that Saturn had a moon get too close, an icy moon, maybe like Titan, because Titan's outer layers are also ice. And it got too close, and Saturn's gravity actually ripped it apart, and the rocky core crashed into the planet, and the rings formed from the icy outer layers of that moon. They actually got broken up into billions of little pieces. And now those billions of pieces all orbit Saturn, almost like billions of little moons in the form of the rings. So we do think it started from a moon.
I'm going to do one more, which is, because I want to know the answer to this, which is, what is the distance between Saturn's like atmosphere and the beginning of the ring system?
So that's actually a little bit tricky to say, because the atmosphere doesn't have a hard outer edge, and the rings don't really have a hard inner edge. But it is, there's a nice few 1,000-mile gap there, which Cassini actually flew through in its final orbits. It did dive between Saturn and the rings before eventually crashing into Saturn's atmosphere. We were a little worried that that region would have a lot of ring particles in it. It was pretty empty. It's hard to, again, say that there's a definite cutoff where the inner rings end and a definite cutoff where the atmosphere ends, but there's a good few 1,000-mile gap there.
All right, I do think we do need to wrap it up. So I think that was our last question. Thank you all for joining us today and for giving us your really good questions to ask. Thank you for taking us on the journey through space, Katie and Talia. I'll let you guys say goodbye and then mute your videos.
Bye, everybody.
Thanks, everyone.
And as I said, I want to thank you all for joining us. I'm sorry I couldn't get to everybody's questions. You guys had lots of really good ones today. If you enjoyed this program, we do more programs like this. You can just look for that virtual planetarium tag on our social media. We'll have one on Friday about what's up in the sky tonight. So if you want to catch that one, keep an eye out for that. You can see what other virtual programs we're talking about, all different kinds of topics about science, by either following us on our social media channels of the museum or checking out www.mos.org/mos@home. And if you enjoyed today's presentation and would like to support more programming like this, please visit engaged.mos.org/welcome to support MOS at home. And as Talia mentioned earlier today, today's program was produced using the free software OpenSpace, which you can find at www.openspaceproject.com. Thank you all for participating today, and we hope you'll join us again soon.